Hello, grade 9 learners. My name is Tutu, and in today's lesson, we'll be adding, subtracting like terms, applying the distributive law, as well as multiplying two binomials. So there's quite a lot in this lesson that you need to be aware of. So let's start the lesson. First start is what we call like terms. Like terms that have same variables and the same exponents. So very important, you must have the same variables and the same exponents. So that is what we define as like terms. Always remember, variables must be the same, and the exponents of those variables must also be the same. Now, what's important about like terms is that like terms can be added or subtracted from each other. So like terms can be added or subtracted from each other. So only with like terms can we add or subtract them. Right? So let us look at the following and identify whether are the following like terms or not. So the question is, are the following like terms or not? So let's give it the following. Let's look at A. We have 2x, 5x, and 6x. So if you look at 2x, 5x, and 6x, we want to know, are they like terms or not? Remember, the definition is they must have the same variables, and those variables must also have the same exponents. That's what's important. We don't look at the coefficients, we look at the variables. Don't look at the numerical coefficients, and look at the variables. If you notice, we have a variable of x, x, and x for all three terms, and the exponent of x, x, and x is 1, 1, and 1. So it means all three terms that are here are like terms. So here it will be yes. Well, I'll just put a tick to indicate that all three are like terms because they contain the same variables and the same exponents. So let's get the second option here. We have 4xy and 3y(x). If you want to know whether other two terms that are on the board there are they like terms or not. The definition, same variables, and those variables must have the same exponents. Now let us observe. We have x and y as variables for the first term, and we have y and x as the variables for the second term. So are the variables the same? Yes. Are the exponents of the variables the same? The exponent of x is 1, the exponent of y is 1. For the second term, the exponent of y is 1, the exponent of x is 1. So yes, the two are like terms, even though you notice that the second term is not written in alphabetical order. The variables are not written in alphabetical order. Natural fact, whenever you're dealing with such an expression, it's important that you follow the conventions of writing algebraic expressions. That means always start with the numerical coefficients if you have more than one factor, and then write the variables in alphabetical order. So it simply means that this term of 3yx can be written as 3xy. Very important that you write the variables if you have more than one factor in alphabetical order. That's the correct way of writing expressions. So you notice the two, yes, are like terms. Variables are the same, and the exponents of the variables are also the same. Let us look at this. 5x squared y and 4xy squared. So look at the next two terms. Are the two terms like terms or not? The variables are the same. You have xy and xy for both terms. However, the exponents of those variables are not the same. You notice the exponent of x is 2, the exponent of y is 1. For the second term, the exponent of x is 1, and the exponent of y is 3. So the exponents of the variables are not the same. Exponent of y is 1, yet the exponent of y is 2. So it means even though the variables are the same, but the exponents of the variables are not the same. So therefore, they are not vectors. These are not related. And then let's look at this one. We have here 9b squared c and 7b squared c. Other two like terms or not. Notice the variables bc, bc, and the variables of those exponents are the same as well, because the exponent of b is 2, the exponent of c is 1, and also correlates for the second term. Exponent of b is 2, exponent of c is 1. So yes, they have the same variables, and the exponents of the variables are the same. So that's what you call like terms. And remember what we also said about like terms. Like terms can be added or subtracted from each other. And that is what we're going to be doing next. We're going to be adding and subtracting like terms from each other. Adding and subtracting like terms. So the questions will come as follows. Will tell us to simplify. We have here 3x minus 4x squared plus 3x minus 10x squared. So now we have these four terms here on the board, and what we need to do is to add and subtract. But you don't just add and subtract randomly. You must first collect your like terms. So we first identify which terms are like terms, we collect them, and then we simplify further. So you notice that the first term contains a variable of x with an exponent of 1. So you need to look for another term that is a variable of x with the exponent of 1, and that will be 2x. So we combine or we group our like terms first. So you combine 3x with 2x, and 2x, remember, is positive. So as you group with the signing of the term. So that will be plus 2x. If you notice, the second term in the original question is negative 4x squared. So we look for a term that has x squared, variable of x, and an exponent of 2. And that, as you notice, will be negative 10x squared. So we group them together. So we have minus 4x squared. Remember, whenever you move around your terms, you move around your term with the sign of the term. And then 10x is also negative. So we'll have the negative 10x squared. Once we've grouped our terms together, all we need to do is to now add and subtract the coefficients of the variables. So the coefficient of x is 3, coefficient of x is 2. We are adding, so 2 plus 3 will give us 5. So it means we have 5x. How many x's do we have? We have 5 x's because we have 3 x's and 2 x's. So now we work with the coefficients. We go to the second pair that we grouped. We have negative 4 minus 10, because you now work with the coefficients. So negative 4 minus 10 will give us negative 14 on the number line. So we have a negative 14x squared. So by that, we've simplified fully. However, the conventions, and you would have learned this in grade 8, the conventions of writing algebraic expressions is that we write them in descending order of the powers of the variable. So whatever the power or the exponent of the variables are, when we rearrange, when we write down your expression, make sure that they go in descending order from the highest exponent to the lowest exponent. So in other words, all we need to do is to rearrange the terms 14x squared is negative. So as you move your term, you move with the sign. So we'll have negative 14x squared, and then 5x is positive. Remember, the operation sign is not indicated in front of the term, which implies that it is positive. So 5x is positive, so we move 5x with the sign, it's positive, and then we'll have 5x. And by that, we have we've simplified our expression and written it in a conventional manner, in a manner we all agreed upon as mathematicians, that is how we would write algebraic expressions. The two can be added. Why not? Because they are not like terms. The exponents of the variables are the same. Right. So B. Let us put this. We're negative 4 pq squared plus 2p squared q and 7p cubed squared plus 5p squared cube. Right, so that's what we have. We have these four terms and want to simplify. In order for us to simplify is to identify the right terms and connect them together. We have p cubed squared, so we're going to look for another term that is p cubed squared, and that term is already there. So that's 2p cubed squared. So we actually have three terms. Let me just check if okay, let me just start that again. Get and I learn this. If you notice the first term, that's pq squared. So we're going to look for another term that is p cubed squared. And which other term is it that is pq squared? That would be negative 7p cubed squared. So it means the first term and the third term are like terms. They must be grouped together. You notice the second term, that's 2p squared q. So another term that is p squared q will be the last term, and that is 5p squared q. And those ones must be grouped together as well. So let's paste those terms together. Group it with negative 7p q squared. Also have here 2p squared q and 5p squared q. Now that we've grouped our like terms, all we need to do is to now work with the numeric coefficients. So we have negative 4 minus 7. Negative 4 minus 7 will give us negative 11. So here we'll have negative 11p q squared. That's when we subtract these two terms. We also have the last pair. So positive 2 plus 5 will give us 7. So here we have positive 7p squared g. So by that, we have added those like terms. And if you notice, the terms that remain are not like terms, because even though the variables are the same, but the exponents of those variables are not the same. And because both terms contain the highest exponent of 2, there's no need for us to rearrange like we did with the first example, where we first started with the term that has the highest exponent and we moved in descending order. In this case, both terms have the highest exponent of t, so it's 5. Was to repeat that. Right, and then this one, that deals with like terms as well. So we have 4t squared minus v plus 5 minus 2v plus 8. So here again, we're adding and subtracting. Now that we're adding and subtracting, we identify like terms. First term contains a variable of t. Is there any other term that is a variable of t? There is no other term that is a variable of t. So simply means the 4t squared, we will continue to hide it, but we're not grouping it with any other term because it does not have a like term. So now let's move on to the second term. Is there another term that contains v? Yes, there is another term that contains v, and that is negative 2v. So we can group these two together. So we have here minus v. So I still have minus v. I wrote it down, and then I just group it with negative 2v because the two are like terms. We have 5, we have 8. The two are constants. So all constants are like terms. All constants will always be classified as like terms because we're adding numbers that don't have any variables. So it means the 5 will be grouped with the 8. So we have positive 5 plus 8. Remember that all constants will automatically be like terms. All constants. So because there's nothing we grouped 4t squared with, we still write it because we can't add or subtract 4t to any other term. It will remain as it is. However, the two terms here, we have negative v minus 2v, which we can subtract the 2. Remember, what's the coefficient of v? It's actually negative 1. So if the 1 is not written there, it means it's there. It's implied that we have 1 there. So we have negative 1 minus 2. And negative 1 minus 2 will give us negative 3. So it means we have negative 3v. And then the constants 8 plus 5 will give us 30. Then we have positive 30. And with that, we can't add or subtract anymore because we don't have any other like terms. So it means the expression will remain as it is, as a simplified value. Good. Now that you know how to add and subtract like terms, we're going to introduce another concept called the distributive law. Now, the distributive law in analysis was taught in grade 8. But in grade 9, we take it a little bit further because we're going to introduce the product of a binomial by a binomial. So the distributive law says following. It says when you multiply a polynomial with a monomial, what you do is that you multiply the monomial with each term inside the bracket. So you multiply the monomial with each term of the polynomial. So simply it's a multiplied by b plus c. For give us, we have a multiplied by b. So a multiplied by b will give us ab. Then the very same factor that is outside of the polynomial we multiply it with the other term. So a multiplied by b gave us ap, and then a multiplied by positive c will give us positive ac. And by that we've applied what we call the distributive law. That is what we call the distributive law. It was taught in grade 8 on how to simplify expressions. So as I said, in grade 9 we take it further. Because we're now going to find the product of a binomial by a binomial. So it means we're going to multiply two binomials together using the distributive law that you learned in grade 8. And there's what it says. It says now, if you have a plus b, which is a binomial that's been multiplied with another binomial called c plus d, what happens if you have such a situation? Check with the distributive law, it's only one factor that is outside of the bracket that's being multiplied with factors inside. Now this time around, we have two terms that we are multiplying with other two terms. Was remember, in between the brackets mean multiply. And if you have two brackets placed together, simply means you're multiplying the two terms inside those brackets. So you're multiplying these two terms, which is a binomial, and those two terms, which is a binomial. And this is what we do. Wait. And then you multiply the first term of the first bracket. So the first term of the first bracket will be multiplied with the first term of the second bracket. By doing what? We actually apply the distributive law, but now that we have two terms. So we take A, we multiply it with C, A multiplied with C, so that will be A multiplied by C, because you distribute to the multiplication sign. So A times C is A times C. Okay, are we done? We're not done. The very same A, so the first term of the first bracket will also be multiplied with the second term of the second bracket. So notice we multiplied A with the first term of the second bracket. Now we also still multiply the very same a with the last term of the bracket. So that will give us, remember, a positive value multiplied by another positive value will be positive. So a times d will be a multiplied by d. Okay. Are we done? We are not done. Now we take the second term of the first bracket and we do the same thing we did with a. We distribute it to the first term of the second bracket. So b multiplied by c will give us positive b times c. Because we're multiplying two positive values, we'll have a positive solution. And then the very same last term of b will be multiplied with the last term of the second bracket. So what we did with a, we also do with b. So that positive times positive will give us positive. B times d will give us b multiplied by d. And if you simplify this further, a times c can be written as ac. A times d can be written as ad. B times c can be written as bc. B times d can be written as be. And by that, we've applied the distributive law, but by multiplying, by finding the product. Product means multiply. So we found we are multiplying a binomial with another binomial. And take note that you distribute term of the first bracket with each term of the second bracket. So now let's do a few examples that apply this knowledge 99 letters. So the statement will always be simplify. Simplify simply means make the expression simpler. Make it simpler, the expression. So that's our way of saying calculate in mathematics if you write the word simplify. So we have 3, the bracket of a minus b, minus 2, the bracket of 2a minus 3b. So now we want to make the expression simpler. So it means we are going to apply the distributive law, or we apply the product of a binomial by a binomial depending on what we have. So if you notice what we have in the expression here, we have one term that's being multiplied, because bracket means multiply, that's being multiplied with the terms inside bracket. So it means we're going to apply the distributive law for simplification of this term. Also, for simplification of the second term, we have one term which is negative 2 that's being multiplied with 2a minus 3b. So again, we apply the distributive law in this case. So what are we going to do? Take the 3, you multiply it with a. 3 times a will give us 3a. Take the 3, you multiply it with negative b. So 3 times negative b will give negative 3b. So we distributed the monomial to the polynomial. And then do the same here with negative 2. So negative 2 times 2a will give us negative 4a. And then negative 2 times negative 3 will give us positive 6. Because the negative value times another negative value is positive. So that will be positive 6. Now that we distributed, it does not stop there. Because remember, a few minutes ago, we learned about the addition and subtraction of like terms. So let's first check, are they like terms? And if they are like terms, let's group them and then we can add or subtract accordingly. So 3a does have a like term, which is negative 4a, because they have the same variable that contain the same exponents. So we group them together. 3b has a like term of positive 6b. So negative 3b is the like term of positive 6b. So we group the two together. Now that we group them, we can then work with the numeric coefficients. So 3 minus 4 will give us negative 1. So we have negative 1a. Negative 3b plus 6b. So negative 3 plus 6 will give us positive 3. So then the positive 3b. And then we stop there for the 2 that are left are not like terms, so they cannot be added or subtracted. Let us read b. Now notice with b, we are simplifying and we have a binomial that's being multiplied with another binomial. So we find the product of two binomials. So what do? You multiply the first term of the first bracket with the first term of the second bracket. So x times x will give us x squared. Why x squared? You multiply powers from the same base, keep the base, and you add exponents. Exponent of x is 1, exponent of x is 1, hence we have x squared. We then do what? Still take the first term of the first bracket to multiply it with the second term of the second bracket. So x multiplied by 1 will give us positive 1x. And what do we do? We then go to the second term of the first bracket and we do the same thing we did with the first term of the first bracket. So the second term of the first bracket will be multiplied with the first term of the second bracket. So 2 times x will leave us positive 2x. And 2 multiplied by positive 1 will give us positive 2. Good. Now that we have applied the distributive law by multiplying the product of the two binomials, we now look for like terms. And if you notice, we do have like terms. The two terms in the middle of our expression are like terms because they have the same variable that have the same exponent. So, and they're already grouped together. So all we need to do is to combine them. So we still have x squared, because there's no like term of x squared, but the 2 can be added. Coefficient of x is 1, coefficient of x is 2, so there will be 1 plus 2 will give us 3, so that will be 3x. And then we still have the constant term of 2, because there is no other like term that can be added to the constant term of 2. And by that, we have simplified our expression. And if you notice, the expression is written in descending order in terms of the exponents of those particular variables. And that is that solution. Now let's get the next example. So yes, the next example. Again, we have the binomial by a binomial. So multiply accordingly. So 2p multiplied by 4p will give us 8p squared. 2p multiplied by negative 2 will give us negative 4p. 6 multiplied by OP would give us 24p. And 6 multiplied by negative 2 will give us negative 12. So do the negative 12. After multiplying, we look for like terms. Are there any like terms? Yes, there are. Like terms would be negative 4p and positive 24p. And because they already go together, ours is just to bed them. We still have 8p squared as a term. Negative 4 plus 24 will give us positive 20. And then we have the negative 12 as our constant term. And by that we have simplified fully because there are no other like terms that can be combined. Now look at this interesting example where we now have a monomial in front of the two binomials. Now what happens? We don't only have two binomials that are being multiplied with each other. We also have a monomial that's also being multiplied with the two binomials. How do we go about simplifying this expression? It's important that first evaluate the two binomials. So first evaluate the two binomials. Only after evaluating the two binomials, then it is advisable that you then multiply the monomial with the polynomial that you would have found after multiplying the two binomials. So simply means keep the factor of negative 2 and find the product of the two binomials. And the product, make sure you find the product inside brackets, because remember you must still multiply the monomial with the polynomial that we get out. So you have here x times x will give us x squared. X times 3 will give us positive x. Negative 2 times x will give us negative x. Negative 2 times 3 will give us negative 6. Notice what happened. We found the product of the two binomials to give us that. And before you multiply the monomial with the polynomial, identify the like terms and combine the like terms. So if you do have like terms, the terms are in the middle. So 3x and negative 2x are like terms, so they can be combined. So 3 minus 2 will give us 1. So there we have positive x and then minus 6. I mean, if 1 is a coefficient, this one will first find the 1. Now that we have added the like terms, it means this is the product of the two binomials. We must still multiply with the monomial that is outside. So then apply the distributive law. We have negative 2 times x squared. So we actually multiply negative 2 with the coefficient of x squared, which is 1. Negative 2 times x squared equals negative 2x. Negative 2 multiplied by positive x will give us negative 2x. Why is it negative? Because positive times negative is negative. And then negative 2 multiplied by negative 6 will give us positive 12. Because when you multiply two negative values, the answer will be positive. And we still continue with the simplification of algebraic expressions. Right, we still continue with our algebraic expressions. So let's get the next example here. What happens if you have a binomial that's raised to the power of 2? Notice you have a binomial that's raised to the power of 2. What we need to do in this case is that, remember, whenever you have a base that's raised to the power of 2, the exponent indicates the number of factors that you have in the expression. So this will indicate how many factors of 2y plus 3 we will have in our expression. So we will have 2 factors of 2y plus 3. So that is what we're doing. We have 2y plus 3 and 2y plus 3. Exponent indicates the number of factors from the same factor, natural factor. Number on the same factor in the expression. If the exponent was 3, then we have 3 factors that are the same. Exponent is 10, we have 10 factors that are the same. So that is the concept behind this. That's the first definition of exponents. Now that we have expressed the expression in terms of 2 identical factors, now you notice that we have a binomial multiplied by another binomial. So what we need to do is to apply the procedure. So we have a 2y multiplied by 3y. So 2 times 2 gives us 4. Y times y will be y squared. 2y multiplied by 3 will give us 2 times 3 will give us 6. We have 6y because we still are multiplied by the factor of y. Then we take a 3. 3 multiplied by 2y will give us 6y as well. And 3 multiplied by 3 will give us positive 9. You look for like terms, they are like terms. Terms in the middle are already like terms. So we still have 4y squared as our term. The 2 can be added. 6 plus 6 will give us 12. So we have 12y. And then we write our constant term, which is 9. By that, we are simplified fully because there are no more like terms. So be aware, whenever you have a binomial raised to the power of 2, always have the number of factors indicated by the exponent. So we have 2 on the same factor. Now let's look at this. You have negative and then x will score all raised to the power of 2. And take note, learners, that when coming into the simplification of algebraic expressions, we will not give you an expression that has more than 2 of the same factor. So it is not an uncommon question for us to give you an exponent that exceeds 2 when coming to the simplification of algebraic expressions. So it will never be 5 or you have 5 of the same factor and then you have to multiply them. We'll always give you an expression or the highest exponent is 2 for you to find the product of that binomial. So we have this now. Now notice with this expression, we have a monomial. We have a negative sign. Remember, the negative sign is always accompanied by 1. There's an invincible 1 that is there. So now we have a monomial with the binomial. What do we do? And now what I said, this binomial is raised to the power of 2. So we have the same factor of x minus 4. How many factors? 2 factors, because the exponent indicates. Still have that product of that monomial. So we still keep that -1, but we still have x minus 4 and s minus 4. So you have two factors of x minus 4. Then what we do, we find the product of the binomials. So the factor of -1 is still there. So we'll have x times x will give us x squared. X times -4 will give us -4x. -4 times x will give us -4x. -4 times -4 will give us positive 16. Like terms are grouped in the middle. So what we have x squared. -4 minus 4 will give us -8x and then plus 16. Notice that the monomial that is being from the original question, we're still keeping it because only now we are going to multiply -1, because remember we have -1 there. Now we're going to multiply the -1 inside the bracket. So -1 times x squared will give us -x squared. -1 times -8x will give us positive 8x. -1 times positive 16 will give us -16. And with that, we have simplified the product of that binomial with a monomial in front of the bracket. Now let's look at this other interesting example. This one involves fractions. So we have 3k minus a half all raised to the power of 2. Whether they are fractions or they are variables, the methods or the procedures stay the same. Doesn't mean if an expression contains fractions, it's difficult. It is not. A fraction is just like any other number in areas. So there will be nothing different about how we simplify that expression. First thing that we notice, this binomial is raised to the power of 2, so you have two vectors. Two identical vectors. Now we multiply, because we multiply this vector and that vector. So 3k multiplied by 3k will give us 9k squared. 3k multiplied by -1/2. So notice that you're multiplying a factor with a fraction. And how do we do that? Because 3 is in the numerical coefficient. Multiply the numbers and then the variable comes after. So this is what happens. We have 3 multiplied by -1/2. How do you multiply 3 with -1/2? It's actually 3 multiplied by -1/2. 3 can be written as a fraction as 3 over 1. We still have the fraction here of -1/2. How do you multiply two fractions? You know from grade 8 that when you multiply two fractions, you simply multiply the numerator and the numerator, denominator and denominator. What happens? Because this value is positive and you multiply with the negative value, positive times negative will give us negative. And then 3 multiplied by 1 will give us 3. 1 multiplied by 2 will give us 2. So it means when we multiply 3 and -1/2, the answer will be -3 divided by 2. So that is what we have. What happens when we multiply 3k with -1/2? We'll have -3 over 2k. So be aware when we multiply two fractions, what do we do? Multiply numerator and numerator, and denominator. We still do the same. Now that we are done multiplying 3k with each term in the second bracket, there's what we have. Once you've done that, now go to the second term or the first bracket and do the same. You multiply it with each term for the second bracket. So -1/2 times 3k will give us the same value of 3k times -1/2. So we still have -3 over 2k. And then -1/2 multiplied by -1/2 is a negative value times another negative value and plus a positive value. And because we're multiplying two fractions, it's -1/2 multiplied by -1/2. Negative times negative is positive. And then 1 times 1 will give us 1. 2 times 2 will give us 4. So we'd have positive a quarter. So we'd have positive a quarter, a 1/4. Good. We multiply those two terms on the first bracket with the other two terms on the second bracket. Now look out for like terms. Any like terms? Yes, there are like terms. Like terms are terms with the same variable that contain the same exponent. So now two terms in the middle of the expression are already like terms and they go together. So ours is simply to simplify it. So we have negative 3 over 2 minus 3 over 2. So we are subtracting two fractions here. What happens if you add or subtract fractions, take minus? It's important that the denominators are the same. So if the denominators are the same, then we can simply subtract the numerator terms. And are they the same? Yes. The denominator here is 2, the denominator there is 2. So because the denominators are the same, we can simply subtract the numerator terms. Negative 3 minus 3, it gives us negative 6. So you're like negative 6 over 2. Okay. Where does the negative 6 come from? We subtracted the numerator terms because the denominators are the same. If the denominators were not the same, we'd have to find the lowest common denominator and then work from there. We then get the quarter. And now that we subtracted the two fraction terms, what we can do is to simplify it further. Because we can actually simplify this fraction, because 2 easily factor f6. So 2 does divide into 6. So how many times does 2 go into 6? It goes 3 times. So we'll have 9 k squared minus 3k with the factor of k still there, and plus a quarter plus 1 over 4. And by that, we have simplified our expression fully because there are no more like terms in the expression. And again, the analysis, just because the question contains a fraction does not mean it is difficult. It will still be simplified provided that you apply the correct rules. And one last question. That deals with the product of a binomial by a binomial. See, now here we have x minus 4 all squared minus 2 into 3k or 3x plus 6. So now that's what we have. There's a typical exam question that is normally asked at the level of grade 9. So first thing we need to do, expand out. So we have two identical factors. Then what we can do, because we have a monomial multiplied by a monomial, we can easily distribute. So then we give us negative 6x minus 5 was negative 2 times 3x of negative 6x, negative 2 times 6, it gives us negative 12. Still like this binomial, so what we do, multiply x and x, so 3 plus x squared, multiply x with negative 4, that's negative equal x, multiply negative 4 with x, that's negative 4. Multiply negative 4 and negative 4, then negative 16. We still have those terms. Now we go for like terms. Like terms, if you notice, for negative 4x and negative 4x are like terms, as well as negative 6x. And the two constants are also like terms as well, so we need to combine them. So we still have x squared as our term there. Now we group the like terms. So we have negative 4x minus 4x minus 6. And then we group the three constants together. And now negative 4 minus 4 will give us negative 8. Negative 8 minus 6 will give us negative 14. So here we'll have x point minus 14x. That's when we combine all the x's together. And then 16 minus 12 will give us positive 4. There's our solution. Now if you look at this question, it included two concepts. Product of a binomial as well as a polynomial that's been multiplied by a monomial. But no matter how complicated it might look, if you understand the procedures, the rules will never change. And with that, grade 9 letters, it brings us to the end of our lesson today, and I hope we enjoyed it. Thank you.